Okay. All good. So how was static NAT for you all? You managed to finish it? Well, you did, right? It's great. If you're confident now, you can configure static NAT.
Yeah.
Brilliant. Right, mixed flag as well. Here we go. So now on to dynamic NAT. How is that configured? So whoever didn't catch the first part of the lesson, I have put the video on already onto WhatsApp.
I have it.
Oh. You were here. But anyway.
I was here, but I didn't.
So it's in YouTube, okay, so you can watch that again. Okay, so dynamic NAT, static NAT is one-to-one. Dynamic NAT is using a pool of addresses. So similar concepts for inside and outside interfaces, but the allocation of IPs is done a little bit differently. How do we configure dynamic NAT? Step one is you define a pool of global addresses to be used for translation. IP NAT pool is the word. Give it a name, a start IP and an end IP address, so you've got the range. Net mask and prefix length. Step two, configure a standard access list permitting the addresses that should be translated. We looked at access lists when we did ACLs about 2 weeks ago. And it will say these are the addresses we're allowing to be allowing for translation. The way you do it is you access list, you give an access list number, you permit, so it's allowing, and you give the source wildcard. Step three is the translation itself, and we have to bind together the access list with the pool. So IP NAT inside source list, access list number taken from here, pool and the name of the pool taken from here, that name there. So whatever you call that, you must use in this step 3 line. That's like a binding of pool and the address is permitted. Step 4, identify the inside interface and you give it whatever it is, serial, whatever, and then IP NAT inside. And the same thing for the outside interface, IP NAT outside. There's a little example here given, or a dynamic NAT allocation. So we're defining a pool of IP addresses, public IP under the pool name NAT pool 1. There's the IP NAT pool 1 address. So this is the start IP address. This is the end IP address. So there's your range, 226 to 240, with a net mask as well, 224. Define which addresses are translatable. So we're going to permit anything on 192.168.0.0 with that wildcard. Remember, this is a wildcard, so you have to flip it around. So think of it as being reversed. Whenever you do an access list, it's reversible. 255.255.0.0. Therefore, anything here is 0.0 up till the maximum is allowed. So therefore, 10, bit odd that. Well, yeah, 10.10 and 11.10 are both okay because they're both going to be within this net mask. Now the binding, we're going to IP NAT inside source list 1, which is the number 1 from here, and the pool is up here, NAT pool 1, like binds it together. And we work out where's the inside and the outside. So the inside's always on this area here, inside network, S00 this side, and your outside it is that side over there. Right, simple. Okay. So now going back from that, how do I analyze it? So here's an example of dynamic NAT in action. So PC1 over here and PC2, both of them are going to open a web browser for a connection to a web server. R2 is bringing in the packets and checks the translation, says, are these two folk in my permit list? And if they are, in my NAT table, which is, I've already set that up and done the commands and configuration, both 10, 11 are allowed, and they both have a matching global address, which is taken from the pool. Remember, it's 226 to 240, and what you can see here is range is allowed. Okay, the range is allocated there. Let's follow the steps around this. So number 4, oh, did I flip over? I did, yeah, I did. So it's now assigned the address, okay, from the pool, and then it also then updates the NAT table because it's now allocated .10 to 226, just tiny, .10 to 226 and 11.10 to 227. So R2 replaces the inside local source address on each packet with the translated inside global address from the pool. So therefore, as soon as it leaves this territory in this direction, it's stripped off local address and given it a new global address from the pool. Remember, the public IP is the same as what the college was given, but in one IP to all. Here, the new address is here 226, 227. So out it goes. So number 1, you should say 2 here, but some mistakes in these slides, you know. I'm realizing that now. I'm doing it again. It's confusing me, this. This should be a 2, and that should be a 2 also. So inside network 1, look up, allocate your address over to 3, and there we are outside the network. And we now see this as coming from 226. That's how it appears. This other one also is happening concurrently. .10 is being turned into 227. Therefore, the server will see it as 227 if it wants to send something back. So now look at the reverse motion now. The server is now sending it back. The server responds using destination and DA of 226 and to PC2 DA 227. There's another mistake on the slide. Again, why is it doing that? It's confusing.
They're not looking for anyone.
What's that?
They're not looking for anyone to doing corrections.
There might be. What the hell is going on? That should say DA. I should say DA. What the hell is going on anyway? So A and B, R2 looks up each received packet and it forwards it on because R2's got the table, the book of all addresses. Looks up, oh, 226, you want to go there, you want to go 227. Let me look you up. Oh, actually, you want to go now, go to 10. Let's ping you off to 10 and let's ping you off to 11.10. Packet reaches destination. There you go. Verifying dynamic NAT. So some commands. You can clear the translations, just so you have all like refreshed. Clears it all. Clears all entries from the table, the NAT table. Yeah, there's various clear commands here if you need to do that. And here's a show the 2 big commands you need to use. Show IP NAT translations. Show IP NAT translations as verbose. Verbose obviously means more information, and there's a bit more information about timing and seconds and milliseconds and all sorts of stuff there. Some more commands that shows you to clear it. Show IP statistics again, just showing you the kind of detail you can get from that command. Tells you the pool names, the access list commands, and the allocations. There's a configuring dynamic NAT activity next. And then the lab here is both dynamic and static NAT. Okay, and this lab is very similar to your skills test. So this lab you must do. Okay, this is your kind of mandatory labs to work on. Okay, now what follows from here is PAT and also then addressing. So if you want me to, I can stop here and let you work on the configuring of the NAT dynamically. Allow you some time for that. I think maybe half an hour for that. And then we will turn to PAT and troubleshooting. Slide 70 is roughly where it ends, 73 or so. So there's about 15 or so slides to go with this. So I will continue at about 8:30, all right? You should have finished before that, I think. Here we go.
What number is this one?
This is 9216, I think.
9126.
Yeah, that's about right.
30 minutes this video.
Half an hour.
92, I think it's
Half an hour.
9225.
9225. Half an hour should be right for that one.
9225.
Is it?
Yeah.
9225.
Yes. Hopefully that's it.
There you go. Let's resume. Okay, folks, well done for doing that. Good job. Let's talk about PAT now and troubleshooting. Who's listening to hip hop loudly? Kamara, Quinlan, was it you? Don't lie. It was you.
Hands up, no.
Was it Stuart? Listen to Kanye West or something. Right. Drake. Okay. Right, now. Oh, I've got a screen actually. What am I doing? So, configuring the PAT. This is how it's done. Here are the steps now for the port address translation. So we first define the pool of global addresses to be used for what we call overload. Overloading means one IP, we're going to put all the ports through it. So you do your NAT pool, name, again, start IP, end IP, net, mask, and prefix. Then you do your standard access list, which is which addresses can be translated or allowed to be translated. And then we do the overload statement here. What it is, you do the same thing as before. You bind your access list with your pool, and you add the word overload to the end. That's the only new bit. This means use PAT rather than NAT. Identify your inside interface as before, and then your outside interface as before. They're your commands, okay? That's my WhatsApp blabbing away there. So here's a configuration command in practice. You can see here the inside of the network. The NAT pool is being set up. The range again 226 to 240. Net mask 24. That's going to get quite annoying, isn't it, after a while? Okay, so here we go. This is the access list permitting, again, the 192.168.0.0 and the wildcard to be reversed, 255.255.0.0, which means any address in 0 upwards can be used. We are binding, again, the source list 1 with the pool NAT pool 2 and overloading it and adding the interfaces and the IP NAT inside that way and the outside that way. Okay. Now, configuring PAT's single address. It says here, when a public address is assigned to the external interface on the border router, the public address can be used for PAT and translate internal private IP addresses to the public IP address. So the steps here are, this is for a single address. We'll still need the ACL, access controller, to define which addresses get translated. And rather than associating the ACL with a pool, the ACL is associated with an interface that has a public IP address assigned. It just shows you here the access list, the permit, the number. There's your binding, and there's your overload. There's your NAT inside and your NAT outside there. That's the configuring of a single address. Now, analyzing PAT, so you can see what's happening in the stages. Again, these two machines opening a browser for connection to a server. What's different now is we have a port number being used, okay? So look carefully for this. R2 receives, look at the steps 1 and 2. R2 receives, let's get this out of the way, a packet on the inside interface. So it's PC1 to server 1 here. And just as a quick look up, it says, you know what, is 1010 in my list where I can give a translation? And it is, there it is there, 1010 is there. R2 assigns the IP address of the outside interface, adds a port number, and creates a NAT table entry for both packets. So this 1444, the bottom there, is now being added, it's your port number, both on the inside local address and the inside global address. The inside global address is that public IP, okay, which is like masking the inner one. So the R2 is replacing this inside local source address on each packet as it goes out, as it pops out beyond the internal to the external world, takes away that inside local address, replaces it with the inside global address. But what's the same is, though, is the port number. I do believe there's another mistake here. Can you see it? What's going on today exactly with these slides? I do wonder. Spot the mistake. Anybody? Oh, it's in 2 places. Oh, it's in 2 places a mistake, actually. SP is the clue. I don't know why they've given 1444, and that's 1445. and that's 1444 still. I mean, you really need to have the same port number. That's a bit odd. Yeah, I would say it might be a mistake. Anyway, it's there as well. It's a bit strange, really. I think you thought you override that. Okay.
How do we verify this?
How do we check? I think it is a mistake, but when you do the actual activity for PAT, it will become clear in a practical example. So analysing it, each server moving forward, as it's now gone beyond now to the actual destination now, each server responds to the PC1, PC with the originating point, using the destination address or the public address assigned to the external interface on the border router. So that's that destination address now. R2 looks up the received packet, forwards to PC1, because just as a lookup, right? And it finds the destination address and port number there. So just as a lookup. So it knows now it's going back to, was 4, 5. 4 and 5 is this way, right? Destination address is 1010, but it's using 225, which is down here, the global address, to match that, look it up, and it finds that one that goes with it. And then it can go further. Similarly, the other server, PC2 here, same thing. It's trying to get to this destination address, but looking up in the table, it uses 225, 1445 there to look up that originating point. Verifying PATs, these commands are exactly the same, except you'll see more information. If PAT's being used, you also see the port numbers. See that there? See, they're the same address, they're both the same. Yeah, they're the same, it should be the same. And clear IP stats and then show IP NAT stats shows you the whole detail. I don't see the port numbers on this one. Yeah, seeing if the word PAT is actually indicated anywhere here. Or overload even. Can't see it. Don't see the word overload in that at all. I think show IP NAT translations is the real key one here to show the port numbers being used. That's an activity of implementing PAT. I've given you that worksheet. There's a lab also that goes with it. This is not in your skills test. Okay, PAT is not in your skills test. So you don't have to worry about doing this lab, but it's a good one to learn about, because in this college here, for example, we're all using PAT here. And it's probably the skill that you would end up using in an organization when you need to assign and share IP addresses. Okay, port forwarding. This is a slightly different dimension of this. This allows an external device to reach a device on a specific port number. Okay, so if a device is accessing something else on an internal private network, this could be very useful for either peer-to-peer file sharing, web services, and also outgoing FTP. It solves NAT because it only allows translations for traffic destined for external networks at the request of internal devices. So a client here is accessing various ports, Telnet, FTP, and web. Here's a client again. It's trying to get to this IP address over here, this server behind the network, via this small office, home office router here. So wireless routers are also known to be using ports. And when a wireless router is set up, similarly, you do need to specify the addresses that requests should be forwarded to this kind of a router. It just gives suggestions about how you configure port forwarding. So it's trying to get to that particular address. Here's some commands given here for how this is done. Just show you this little diagram on the left-hand side. This establishing a translation between inside local addresses and local port, and an inside global address and global port. There's a binding going on here. This is TCP connection. Here instead, very specifically TCP. That's stuff like web services, yeah? That's what TCP allows. And it's giving me the binding of 254, port 80, which is that device there, and binding it with 225, 200.225 on 8080, which is over here. That .225 is that interface address right there. Okay, that's being bound to this. And it's also setting the inside and outside here and here. And that allows a tunnel effectively straight through to that device, okay, using TCP. For web services, it's very much needed. It's showing you how that works now. It's just showing you the translations and it's showing the details of that. There's also a packet tracer on configuring port forwarding on a wireless router there. A bit about NAT for IP version 6 as we go towards the troubleshooting in the end of this. So IP version 6, as you all know, many millions, trillions of addresses available, okay? So because that was developed, it thought, oh, the whole point of NAT was kind of unnecessary, yeah? But as we still are largely using IP version 4 in lots of places, NAT becomes the sort of supreme protocol and the sort of skill to have for this all work. IP version 6 does have its own form of NAT and its own private address spaces if needed. Okay, they're to create various subnets. They have local addresses that are similar to IP version 4 privates. They've got certain specific names. So this might appear in your theory test. They allow you to create communications within the local site. Here's the kind of way it would look. The prefix is set to that, FC00 to FDFF. Next bit is a 1, and you've got a global ID and a subnet ID. Okay, so it allows sites to be combined without address conflicts and allowing internal connectivity for IP version 6 networks inside an organization. We need to have that kind of communication going on. The rest techniques for this. So the issue is also what happens if you've got a IP version 6 only network and an IP version 6 only network and they're separate. How do you join them together? So there's some techniques. These are covered much further in CCNA 3, where you have look at those kind of approaches. One module called Connecting Networks, CCNA 3. And here you have the issue of old and new networks. What do you do? So the ways of doing it are, there's some approaches. One is called dual stack. Both devices run both protocols, IPv4 and 6. You have to configure everything for both sides of a network. Another one's called tunneling. And this is one where you have to actually put a IP version 6 packet inside an IP version 4 packet and then transmit it that way. Yeah? Can you imagine how that is, you know, in terms of efficiency? The transmission over an IP version 4 only network. Then you've got the translation, and it says here, shouldn't really use it for long-term strategy. And it's called NAT64. This is really hardly used, you know, that stuff. Yeah, but you certainly might come across tunneling and dual stack in your careers. So troubleshooting NAT problems, these are the last bits and pieces here now. What kind of things can go wrong? So again, the commands are very important here. So, you know, what you need to do is look at what the NAT's trying to achieve and compare it with the configuration. And that might reveal a problem there. So show IP NAT translations is the command. You can use the clear and debug commands to allow you to show you what's going on line by line as things are occurring. The debug IP NAT command, debug IP NAT detail, will give you information like this. So what it's showing you is your source IP address, So you look at this key here. Source IP version address, how it's being translated, and the destination IP version 4 address, and the IPv4 identification number. This will show you that the addresses have been designated correctly. So for example here, this is what debug's doing at the top. You see this translation going on there. That's being mapped to that. That's what time it's happening at. Yeah. And the end of that is the destination address, which is that final address there. And I can show you, that's the debugging IP NAT command. Will show you what's happening there, that one. Other types of scenarios. Here, internal host cannot contact external servers. I see what's going wrong here. Okay, it's a little problem here. So number one, you see here, pings are failing from PC1 to get to over here. Yeah. The NAT pool assigned is 226 to 240 in that list. It's trying to do a translation, looking up this internal global address 1010 and 1110 to see what have I got. You know, there's nothing in the NAT pool. There's no translations there. Okay, that's just the first problem we've come across. Nothing is translating. You go over to number 2. Oh, that's how it was found out, by the way. Show IP NAT translations. It's empty, nothing to be shown. Go over here. Show the IP NAT statistics. What you find out is that these interfaces have been reversed. Yeah, they're reversed interfaces. The wrong way around. Outside 00, inside 01. Oh dear. Yeah, so they've been reversed in terms of the way they've been configured. First problem. So what we didn't do is there's number 2 over to number 3. Also, showing the access lists show that there's an incorrect ACL. Look at that IP address there. Can you see why that's wrong? That wildcard is wrong. 000.255. And what does that cause a problem with, looking at these 2 IP addresses?
Only 2 zeros and 255 they should be.
So 10.10, 11.10 are not going to be permitted. If I switch this wildcard around, only, you know, you can have 0 there, but that's going to be up to 255. You can't modify that because that wildcard. That wildcard needs to say 255, 255. That'll allow you to have 10.0, 10.10, 11.10, whatever in that range, okay? So you just look out for those kind of issues and then come across troubleshooting scenarios. The way you fix it is you do no access list 1, that deletes the access list, you put another access list in, permit it, and you write the correct wildcard in. These errors happen all the time. Yeah. Now that's fixed and been reversed, so that's been sorted out, okay? That's been fixed and that's been fixed. These translations are now working, and now show IP NAT translations is giving you a line, and that's now the correct global inside local. Oops. That's now the correct setup there, and now pings will get through. Okay, and they will obviously have a couple of these, you know, ideal for, you know, 8:50 p.m. in the evening to give you some troubleshooting NAT configurations. So for verifying, there's one there, topology, and there's another lab also on troubleshooting NAT configurations too. Okay. So I probably would suggest, I mean, in terms of time, you've got your choice. You can look at the PAT if you wish to. If you can take any, Hermione's holding his head over there.
No.
It's to look at the PAT if you wish to, or just browse through these materials, or if any questions, please fire away. Chapter summary, this is a skills integration challenge. If that's not enough, you get this integration challenge at the end, which is just bringing it all together. But again, the lab I've given you is a crucial thing, okay? So look at that lab. Here's the commands we looked at today, various statements and things we've done. There we go, chapter 9, and only one more chapter to go. I'll give you a little sneak preview of that, actually. Next week's chapter is this. But if only it was PowerPoint, wouldn't that be fun? Just teaching you PowerPoint one lesson. It's device discovery, management, and maintenance. This is like network manager's job now. Network management, how you manage your network. We learn about stuff like this. I'll show you the kind of outcomes section. Device discovery, how you map a topology, how you manage using reporting systems, a network, and you can observe what's happening, and how you do backups, yeah, of your iOS devices. That's chapters, and not so bad, is it? Yeah, and then this is quite a cool chapter, that one. It's quite easy, all right going, that one, understand it. And then that's then also going to include a revision for your skills test. You need to make sure you come for next week's lesson. So I'm going to brief you on your skills test, okay? Please, everyone needs to be there. I'm going to give you about maybe half an hour for just to tell you this is how it's going to work. These are the stages, and I'll give you a topology which you need to go away and make. You bring it back next week, and I check it, you know, make sure it's all right, and then you can take it from there. All right? Good. Right, folks, over to you now. Any questions?